Euler's method is a numerical technique for approximating solutions to first-order ordinary differential equations, like the one written here in this box, when an exact solution is difficult or impossible to find. Euler's method is one of the simplest numerical methods for solving a first-order ordinary differential equation. Instead of finding an exact solution, it uses the slope f of xy that's given up here in the equation to step forward from a known starting point, which we're going to call x0, y0, and that comes from the initial condition y of x0 is equal to y0, and then build an approximate solution that we're going to call x sub n, y sub n, point by point. If we look down here on our graph, we can see that our initial condition x0, y0 is what the solution is initially equal to, and then x1, y1 right here approximates this solution, and then the next approximate solution, x2, y2, approximates this solution. Notice that x0, x1, and x2 are all equally separated by a value that we'll call h, and that's called the step size. Let's now see where the formula for Euler's method comes from. Over here on the right, we can see that the point x0, y0 is the point that we start with. That's the initial condition. And then the point x1, y1 is the first approximation. To find the approximate value for y1, we're going to use the fact that this green line is the slope of the tangent line to the solution at x0, y0. If we look back up here at the original equation, the slope is given by dy dx, and it's equal to f of xy. So we can say that f at x0, y0, which is the slope, is equal to y1 minus y0, all divided by x1 minus x0. We want to find y1, which is right here, so that's the one that we're going to solve for. If we multiply things through, we get that y1 is y0 plus our function, which is our slope, times x1 minus x0. If we look back at the graph on the left, you can see that x1 minus x0 is equal to h. So we're going to plug that in. That's right here. And that's our formula for y1. This same process is used to find y2 and all the other y's. And this leads us to the formula that we're going to use. And that formula is y sub n plus 1 is equal to y sub n plus h times f of xn, yn. I want to make one more note about step size. Using a smaller step size h generally produces a more accurate approximation. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.